Swayam Prabha. Digital India. Educated India.
Welcome to this second lecture on precedence diagramming method, and in this session we are going to cover the following topics. We are going to discuss a few of the issues with precedence diagramming method. We'll talk about analysis with non-continuous duration, and you will see that from our earlier lecture where we tried to keep the duration continuous, there will be a difference in this approach when we use it, and it's probably more realistic. We will also discuss floats in the precedence diagramming method. This is in many books the floats are shown as very similar to AON and AOA, but we will see that there are some other kinds of floats that can be defined in the PDM. We'll talk about calculation of the floats, and then briefly we'll discuss application issues. Most of the lecture will be on the concepts of PDM. I think when we get to applications, there's a lot to discuss, but the framework of this course does not allow us the time for that, but you will certainly get some flavors of it, which you can probably read and get to the details later. Now, one thing which we have to do is to be able to understand why we have to handle PDM with care. So let me take this example. We have seen some examples like this before. So basically I have three activities A, B, C, and I have a end which is there, and I have defined different relationships. So you can see A to B, there's a start relationship and a finish relationship, okay, with 4, with a lag of 4 and a lag of 1, and BC again there's a start finish relationship, but you will see the finish relationship has a -2, okay, so it's kind of a lag. So this is something which we want to see how the analysis behaves when we put a negative value in the lag. Okay, so basically we are giving it basically a lead. So if I'm going to start with 0, as we have done earlier, you will find that it goes from so I will start, the early start for A is 0. I go with the duration here and get an early finish of 10, and then now A leads on to B. Because there's a start relationship with a lag of 4, if A starts at 4, B would be, A starts at 0, B would start at 4. Okay, that's the early start. The earliest B can start is at 4, and now B has a duration of 8. So one of the options is for B to, the early finish could be 12, or if I come with the other relationship, that is the finish relationship from A, the early finish is at 10. And if I use the finish relationship and count, it should finish by 11. So when I take between 11 and 12 is more constraining. So I keep 12 as the early finish and then move on to the next activity, which is C. So here again you have a start relationship of 2 between B and C. So the 4, when I come down to C using the lag of 2, C, the early start of C becomes 6, and going through the duration of C 14, the early finish of C becomes 20. Now using the finish relationship, remember we were at 12 here. Now we come with the finish of -2, okay, so it goes to 10, and based on this we should be able to take the next step, which is to look at how does this then go on to the end. Now we have a basic finish start relationship at the end, and we see that this has gone on to 20, because we are taking the 20 from the early finish of C. So as this goes to 20, and end is kind of a dummy activity, so we end with 20, and this took care of the forward pass. Now as we get to the backward pass, we will see we come back 20, that's okay, and then we take the 20 back here, and then with the late start of C we get 20 minus 14, which is 6, that's also fine. So this is the late finish of C and the late start of C. Now when we go to B, remember there is a lead, a negative lag. So when we go in here, we actually land up with 22. So as 20 goes to the finish of B, we land up with 22. But do realize that we cannot do 22 because the project duration itself is 20. So how do we handle this situation? Okay, so one probably common sense way of going about is saying, oh, this should not exceed project duration. So I go ahead and put 20 as a project duration, the maximum it can be is a project duration, and continue down with the analysis. So if I went back here, 6 minus the 2 here goes to 4, and 4 minus 4 is 0, and I proceed this way. Now I am able to get an inconsistency here. Okay, so this kind of issues have been discussed quite a bit in PDM literature, and this whole business of negative lags has got a lot of attention, and there's a lot of publications on this. So you can see the first publication from Journal of Operations Research saying precedence diagramming method, some unusual characteristics and their implications, highlights these issues. Or another publication here from AAC, this is called the Great Negative Lag Debate. So here the paper actually talks about how some practitioners actually like to use the negative lag and are able to handle it properly. So there is, so certainly the software that's available allows you to use negative lag, but in basic analysis and for starting, it is really recommended that you don't use negative lags at all. And in fact, the question of how much of PDM should be used as a starting planning engineer is also, there is a lot of discussion going on that. Now remember, we had I had given this problem in the end of the last lecture, and if you notice, there are two relationships here with negative lags, and if you had actually solved this, you would have, we can actually try to go through the process of solving it and see what the issues which come up are. So here we see this is the network, and I have shown the different relationships. So we have all the activities. We have the start relationship here, the finish start. We have a finish relationship here, finish start with +2. Here is the finish with a negative lag, and the finish start with a negative lag. So as we do the forward pass on this, okay, this is fairly standard. We would go with this, we would go to 0 to 7, then A goes from 0 to 7, B from 0 to 5, okay, and then we go from C, because of the the +3, the lag in +3, it goes to 3. So the early start of C becomes 3 to 14, and D is 0 to 10. Okay, I'm going to go through this, and I will stop where there are interesting issues that are happening. So here again we had 7, because it's a negative lag, its early start is 6, and then plus the duration gives 11. Here we have two options. We have the option from 10 and from 7, and we apply the early start, which is a maximum early finish of predecessor rule, and we get 10, 8, and then we go to 18 here. And we go on with 14, 22, and now when we come here, we have an issue that crops up. When we come from this direction, we have 11, and 4, we could get 15. We come from the other direction, we go to 22, and it's a negative lag. We go to 20, and we go back here at 16. So if I want to do this activity continuously, should I go from 16 to 20? Okay, because this is what is constraining me as per the early finish rule from here. Okay, from this relationship. Now, so this is an area which requires attention, and then as we go through, and this is assuming that I want to do it in 4 continuous days. Okay, how do I go about doing it? If I go in to the next relationship, so I have between 18 and 15, I have a +3. Okay, so one option is to come with 18 and 21. The other option is to go from 16 and 12, 28, and obviously the 16 and 28 is what is controlling this activity. Similarly, we come out here 14, 17. So all my forward pass durations have been calculated, and I get 28 as the project duration, and now I start the backward pass. So as we go over the backward pass, again my late finish, my late start, late finish, late start, late finish, late start. I go back here, so here I have this is the only relationship, so it's 28 minus 3, that is coming to 25, and then back here I have two options, that is one is 14, that is coming from 16 and 2, that will be 14, or 25. I go with the minimum here, and so on. As I go back, most of these are fairly standard except here now. Again we are facing this problem where, because I have a negative lag, the late finish of H is exceeding the project duration of 28. So this is going to cause problems. So if I go down this path, it is not going to give me a proper value. So I'm going to actually again say that, oh, this cannot exceed project duration, and take this path, take this as 28 and use that as the limit, and then go down based on 28, 20, and then 28 minus 8 being 20, and then go down the backward pass. Now as we come to A, again A has, you have a start relationship with C, you have a finish start relationship with F, and you have a finish start relationship with G. As you get values from here, you will see that again the start of A is different from the finish of A. Okay, the finish of A might be controlled. So if I start A on 6 and finish, when should I finish A? I can finish A on 13 if I am doing it as continuously. If I start A, for example, on 13, it will delay the late start of A, it will delay the late start of C, which is not acceptable. So I have to start on or before 6, and I have to finish by 13, but do I really need to finish by 13? If I finish later than 13, what happens? Really, you can see that none of these activities get affected. So why am I constraining myself? So this is the question that we need to see.